Welcome to qnawire.
Two blocks are lying on the horizontal floor. Here we have at mass 2 and this is mass 1. Mass 1 moves towards mass 2 and elastically collides with M2. So we are asked in a part A of the problem, we are asked at t is equal to 0, what is the center of a mass of a two-block system? So in order to find it, each block is assumed to have a density uniform density. So the center of mass of each block is its geometric center, which is given from the table at t is equal to 0, plugging these positions at each block in the equation that for center of mass, which is m1 x1 plus m2 x2 divided by m1 plus m2. This gives us x center of mass to be at t is equal to 0 to be minus 0.50 meter. Part B, noting that the left edge of the block 2 is in the middle of which at x is equal to 0 is at x is equal to minus 2.5 centimeter. So at the moment they touch the right edge of the block 1 is at x is equal to minus 2.5 centimeter. Thus the middle of the block 1 is at x is equal to minus 5.5 centimeter. Putting these position for the middle one and the block masses in the equation that we wrote previously, this gives us the center of a mass at t is equal to 1.93 seconds to be so let me just write t here, t separately. T is equal to be 1.93 seconds, the center of mass to be at minus 1.83 centimeter or minus 0.018 meter. Part C, we could figure out where the blocks are at t is equal to 4 seconds using again the equation that we wrote previously for part A for the center of mass. So we can write then the V center of mass will be m1 v1 plus m2 v2 divided by m1 plus m2. That gives us 0.25 meter per second in I direction. This is the center of mass moving at a constant velocity of 0.25 meter per second. Then we can write x center of mass will be x center of mass initial plus v center of mass that we just found times t. Then substituting values minus 0.5 or initial meter plus 0.25 times 4 seconds. At 4 seconds, then we have the center of mass at plus 0.50 meter.